Hello, Didex. How are you? Yes, I haven't been following the daily lately, but binary search is something that comes up often. In this case, that's pretty much all you need. Sometimes there's another insight. Okay, so have you solved it? I guess so. Maybe I can teach in the daily. You mean the next one, right? I think they'll publish it in half an hour. I wanted to teach maybe a couple of tricks and maybe a few ideas on how to think about binary search. So let's start by reading the problem. So you are given the amount of time you have to reach the office. They say that you take n trains in sequential order to commute to the office, and you are given an array with all the distances for each of the train rides in kilometers. And here it's an important part is that at an integer hour only. So here you get an example, and if you take the first train, it takes 1 hour and a half, then you have to wait half an hour more to take the second train, and so on. And you're asked to find the minimum positive integer in kilometers per hour that all the trains must travel at for you to reach the office on time, or -1 if it's impossible to be on time. The answer will not exceed 10 to the 7. Oh, I did not read this. I mean, I don't think you need this. And this is an interesting point. I mean, it doesn't seem necessary, but I want to show a way on how to use this. So why do we think this is a binary search problem? Because you're being asked to find the minimum speed, and it's clear that if you can reach the office on time for some speed, then you are going to reach it as well for higher speeds. So this function that tells you whether you can reach the office or not for every integer speed. Yes, so that's what I'm going to teach a way to avoid doubles, so that you don't have to deal with precision errors. And so what I was saying is that this function is monotonic, which is what you need in order to do binary search, in the sense that for speed 0 you cannot reach it, and you are going to have a sequence of speeds with false that do not reach the office on time, and eventually you get a speed that can reach, and so on, and then you will have all truths. Yes, it's strict. Well, not as strictly. You don't need that, but my point is that you're turning this into a Boolean function where you get all falses like a sequence of falses and then all truths. And you want to know where the first true value, that's going to be the minimum that you're asked. So yes, in order to avoid dealing with the float, since you are told that it has at most 2 digits, that means that if you multiply the hours by 100, then you will have an integer. So if we round it just to make sure that we get an integer, even if there's a small error in the number, then we turn the hour into an integer, which I guess we can call it, it's 100 times the hour. So maybe the hour is not a good name. Maybe we can call it hour 100. Anyways, so then we can think about a function good that we're gonna give it a speed, and it's going to tell us whether we can reach the office on time for that speed or not. But let's imagine that we have that. So now we can do the binary search is always the same. That's something that I want to. So the way that I implement the binary search is that first I want to have the two inclusive ends of the range, and the invariant is going to be that for low good is false, and for high good is going to be true. So that means that if we keep making the interval smaller by half, eventually low and high are going to be consecutive, and since low is always false and high is always true, then high is going to be the smallest true, which is what we are looking for. So we check the middle, and if the middle is good, then it means we said that high is always good, and low, if it's not good, the middle, then we said low, and high is what we're looking for. So you can code this by, it's always the same idea. So now, how do we initialize high so that it's initially true? Well, here there's a catch, because there's a special case where we have to return -1, in which it is impossible to be on time. So there might not be any high that is true. So one way to think about this is, if we set high, if the speed is larger than all of the distances, that means that the time that you need to spend on each train is only 1 hour. Is only 1 hour, which is the minimum, because of the condition that you need to wait to the next hour to get the next train. So yes, there are different ways of dealing with. I think this is the simplest, because you don't you don't need to deal with that. I mean, you don't need to optimize and end early. I mean, the binary search is fast enough, it's going to be logarithmic time. So I think this is the easiest way. I always code it this way. It's important to know what your invariant is to make sure that you maintain it, and then you have the condition that you want at the end on termination. So what I'm saying is that if you set high, if your speed is higher than or equal to the maximum of the distances, then all of them are going to be 1. All the times, the hours, it's going to be 1. You're going to need n. Well, but there's the exception of the last one, because on the last one you don't need to wait for the next train because there is no next train. So in that case, you just divide by the speed, and that gives you the time it takes for the last train to get to the office. And here, something that we can take into account is that since the time, the hour, where it's said that it has only 2 digits after the decimal point, that means that if we make the time of the last train low enough, then we can make sure that it's not gonna make a difference. Let me show you that. I always get confused by different binary searches I see floating around. Yes, I mean, my recommendation to avoid confusion is to think about that's key in binary search and in many algorithms, but especially in binary search. And then my approach is to pick this way, which is, I think it's the simplest that I've seen, and then stick to it, because there are different flavors of the same thing. Essentially, you can use any. So what I'm saying, so we have the distances. Let's say that we have distance 1 plus distance 2, and so on, and then distance n. But to calculate the time, we need to divide by the speed, and we want to round up, because that is what it's going to make sure that we wait for the next train. So this is what we want. Maybe we can also write the n minus 1, because the last one is different. The last one doesn't have we are not rounding up, like I said, and we want to know if this is less than hour. Okay, so we can compute all these numbers. All these numbers are integers, but here this is not an integer and this is not an integer, but one thing that you can do when you don't have integers is to, instead of dividing, multiplying, when you have an inequality, so here we can multiply by s on both sides, and this s gets cancelled, and now this is not being divided. And then, but we said that we have 100 hours, so we can divide by 100 and multiply by 100. And now again, since we have 100 dividing, then we can cancel it and move it here. And now we have a condition that only includes integers, and we don't have to worry about any precision. So let's see how this looks like. We want the distances all the distances except, how do we do this? So we want to, yes, maybe we can call it like this, and we want all except the last one. And well, another trick to divide with the ceiling is to add the divisor -1 and use integer division. That's going to give us the ceiling without and keeping everything in integers. So then what did we say here? So here we have to be careful because this 100 is multiplying. So S is multiplying this, which is the speed, and this, then the 100 is multiplying everything. So here we have the last distance, and this is going to multiply the speed, and then maybe this is going to be a little long, but it doesn't matter. And here we want our 100 times the speed, I think it was. Yes, because here we have 100 times the hour times the speed. So this should be good. And then, like I said, if we get the maximum of the distances, but then we multiply it by 100, that means that the time, since this is, even if the maximum distance is the last one, since this is, the speed is 100 times the last distance, then we are going to get 0.01 as the time of the last train, and that has to be less than whatever extra we have in the hours. So that means that if we cannot do it, if it's not good here, then we have to return -1. And I think this should do it. Okay, this was a little too long. That's why I messed up the parentheses, but I think I have too many there. And let's see. Let me check something up. Oh, here I think I want all except the last one. So that's wrong. Yes, that looks better. Yep. And we're 10 minutes to go from missing the daily, and we solved it. Daily coding challenge completed. Nice. So yes, a few tricks to take away here. Yes, whenever you have an inequality and you're dividing, you can multiply by the denominator, and that way you can eliminate all the non-integer numbers. You have to be careful with other languages. In Python it doesn't matter, but in other languages you have to be careful not to overflow. I think in this problem you probably need to use long C++, like 64-bit signed integers. But I think it's worth it to make things bulletproof. And then this was another key. I think you could also just use this part from the statement. They say that the answer will not exceed 10 to the 7, so I guess you could just add that here, like put 10 to the 7, and that should work. But I wanted to give like an argument that it's only based on this. Oftentimes you can just find the upper bound of the search of the initial interval. You can find it with an exponential search. Like we want high to be good, so here we could do high times 2 if it's not good, so we keep growing high exponentially until it is good. But the problem is that here you can get an infinite loop, because there could not be any good speeds for this problem. And again, you can even copy paste this. I mean, it's so simple when you understand it that I just type it, but it's always typing the same thing. And then this little trick of having 100 times the hour, again, to avoid any floating point shenanigans. So yeah, I think there you learned a couple of tricks, an example of binary search, and I think this is a simple way to solve the daily. So that's all I have for now, and see you in the next one. Bye bye.